we are going to start with inductive reasoning. Inductive reasoning is making a conclusion Guys, if you did not pick up notes, they're over here, okay? Making a conclusion based on observations and patterns. So that's what we are doing today. We are going to make conclusions based on observations and patterns. Then you have something called a conjecture. A conjecture is a concluding statement reached using inductive reasoning. So we are using inductive reasoning to make a conjecture, okay? Okay, so it says find the next 5 terms of the sequence, then write a conjecture. So you need to identify the pattern. 38, 31, 24, 17. What do we think would be next? So what would be next? 10, then 3, then -4, then -11, then -18. So we used our inductive reasoning to finish the pattern. Now we're going to write our conjecture. Okay? So we would say to generate the next term, you subtract 7 from the previous term. Notice your conjecture is a sentence, okay? Okay, looking at number 2, do we see a pattern?
Times 2 plus 1.
Double it and plus 1. What's 2 times 2?
4.
Plus 1. What's 5 times 2? Plus 1. What's 11 times 2?
22.
Plus 1. 23. What's 23 times 2?
26.
What's 23 times 2?
46.
Plus 1.
47.
47 times 2?
94.
Plus 1. 95 times 2? 190 plus 1? 191 times 2? 382 plus 1? 383 times 2 plus 1? 767. Okay, so we finished our pattern. So our conjecture is going to be to generate the next term. Double the previous term and add 1. What do we think is true about number 3?
Oh, okay, so adding by 2, like, don't,
What you start at 3, and then you go by 2.
Okay.
5, and then add 7.
And then you would add 9, then 11. Okay, that's true. But let's think a different way of adding. Let's get away from adding. What do we notice about 1, 4, 9, and 16? Do what?
they're all square.
They're all perfect squares. They are all perfect squares. 1 squared is? 2 squared is? 4. 3 squared is? 9. 16 squared is? Well, 4 squared is? 5 squared is? 25. 6 squared is? 7 squared? 8 squared? And 9 squared. So they are all perfect squares. Okay, so each term is a perfect square. To find the nth term, you square n. So to find the 15th term in your sequence, you would do 15 squared. So they're not always going to be adding or subtracting a value from one term to the next. Okay? And do patterns always have to be numbers? No, patterns can be letters. Okay? What do we notice here?
2 letters.
You skip 2 letters, so you go up 3 letters. Okay? So A, and then B, C, D, E, F, G, H, I, J, K, L, M, so M's my next one, N, O, P, Q, R, S, T, U, V, W, X, Y. So, wrong color. Stop. So who's absent? You're missing. We are missing Keaton. And we are missing Parker. Yeah, go quickly. Okay, and then save. Alright guys, I'm taking attendance on my phone really quick so I don't have to stop recording whenever he comes back. Okay, so to generate the next term, you do what? How do we find our next terms, guys? We skipped how many letters in the alphabet?
Skip 2 letters.
You skip 2 letters after the previous term. Okay, next one we have 7:30, 7:55, 8:20, 8:45, 9:10, 9:35, 10, 10:25. Okay, so to generate the next term, you do what? Add 25 what? 25 minutes to the previous term. Guys, could I just say you add 25? No, because time works differently than just numbers, right? Yes, sir.
Well, can you say 25 because like you don't know for sure it's minutes?
So if I add 25 to this, I would get 870.
No, I mean
It's like
like
9 days and 10 hours.
I mean like yeah, like 6. It could be like 8 seconds and 45.
Okay, so then you would have to say you add 25 seconds to the previous term.
So you can do whatever, you just can't do
As long as it makes sense. There could be more than one right answer. But guys, when we see this, what do we think of? Minute and hours, right? Isn't that normally how we see it? Because if it was seconds, it would be dot. When you do a second, it would be dot instead of the, what is that, a semicolon? Colon? What do you call that? My English tuition knowledge isn't. Y'all don't know any of that? Isn't that what y'all learn in English? Yes, y'all do. But that's why it would be different, Cooper. This next one's tricky.
Times it by the next one.
3 times 1's 4?
I know, 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6.
Okay. So you could add the previous, no, because 1 plus 4 is,
I know, like, yeah, 3 plus the next, yeah.
It would be 1 6.
okay,
6, 1, 7, 1.
okay. Try something else. Get away from pluses. 3, 1, 4. What's that?
Oh, 3 times.
That's pi! Oh, 3.14. That's pi. Pi is 3.1415. 926. Anyone know more?
5.
5.
3.
3. Good job. Okay. So, each term is a digit of pi. To find the nth term, find the nth digit of pi. Quickly. Good? So those are us making our conjectures. We are looking at our pattern and saying how we complete the pattern or what's going on with the pattern. Okay? Now we are going to go to counter examples. A counter example, what do we think a counter example is, guys? It's pretty much in the name. Something that's not an example, something that's breaking the rule. Okay, so it's an example that shows a conjecture is false. So we are going to look at a bunch of different conjectures. And we're going to determine if it's true or false. Okay, it's true if we can't think of any counterexamples. It's false if we can come up with something that makes it not true. And then we're going to say what our counterexample is. Okay, so if it's true, you don't need to put a counterexample. If it's false, then we put what our counterexample is. Okay? So the sum of any two consecutive integers is always odd. What does that mean? Is that true or false? True, because if you think about it, guys, consecutive numbers. Okay, consecutive numbers are numbers that are next to each other. Don't our numbers go even, odd, even, odd, even, odd? So if you're adding two numbers together, you're always going to be adding an even number with an odd number. Anytime you add an even and an odd, you get, like, what's 1 plus 3? What's 1 plus 2? Which is what kind of number? Odd. What's 9 plus 10? 19. Odd. What's 20 plus 21? 41, which is odd. So is it true that anytime you add two consecutive numbers, it's going to be odd? Yes, that's true. The product, what's product mean, guys? So we're multiplying. The product of two numbers is always larger than either number. Okay, false. Can you think of a counterexample? Say it again. Okay, 1 times 1. Say it again. 0 times 1. What's 0 times 1? 0. 0 is not larger than 1. Okay, so this one is false. We said 1 times 1 is 1. So it's not larger than either number. Okay, we said 1 times 0, which is 0. 0 is not larger than either number. What about if we do like fractions? Like what if we take a half of 4? Is that larger than both numbers? No. Okay, so all of these would be counterexamples. That conjecture is not true, it's false. Okay, the product of two perfect squares is always a perfect square. Do we think true? Okay, so if you're shaking your head no, you got to come up with an example.
4 plus 16 is
product.
Well,
Multiply.
4 times 16
Is 64 a perfect square? Yep. Huh? It's true. The product of two perfect squares is always a perfect square. Okay, if the area of a rectangle is 6 meters square, then the dimensions must be 2 and 3. False. Why is that false?
Because 6 has more. It's a prime number. I mean, 6 is the other one, so like you can multiply by like 1 and 6.
Okay, so 1 meter times 6 meters. And that would give you an area of 6 meters. That's not 2 and 3. So there are other dimensions that can multiply and give you an area of 6 meters squared. Okay. Number 11, dividing by 2 always results in a number less than the original number. What would be a counter example, Mikey?
0 divided by 2.
False. 0 divided by 2 is 0. So I divided 2 by 0 and I got 0. Is 0 less than 0? No, they're equal. What would be another example?
10 divided by 1.
We are dividing by 2. You always have to divide by 2. So what over 2 would give you a larger number? Yes.
A negative number?
A negative number. What if we did negative 4 over 2? What's that? Is that smaller than the original? No. It's larger. Okay, so this is not true. Okay, vertical angles are never complementary angles. So this takes into last unit's knowledge of vocabulary. What are vertical angles, guys? So two lines that intersect, they are the angles that are next to each other? Opposite each other. So two intersecting lines, those are the angles opposite each other. Okay? Can those angles ever be complementary? What does it say? Complementary? No? Yeah, why couldn't they be?
But they have to be like back and back.
The only thing with vertical angles is they have to be equal to each other. So for them to be complementary, could they both be 45 degrees? Yeah, why not? Okay. So false. If the vertical angles measure is 45 degrees, then they're complementary. So an example of that, guys, would be like I have this would be 45 degrees, 45 degrees, 135 degrees. These two angles are vertical angles. Add them together and you get 90. This works. Okay. Okay, 13, if A times B equals 0, then A equals 0 or B equals 0. Is there any way to multiply two things together and get 0 other than one of the two factors being 0?
No.
No, so is this true? Yes, one of them has to be equal to 0. You learned that in algebra. That was called your zero product property. Okay, if you have two things multiplied together and equals 0, one of the two pieces has to be 0. Okay, two angles supplementary to the same angle must be congruent. So let's look at up here. If I have this angle, what's supplementary to 135? 45. Okay. And if I look this way, this angle is also supplementary to 135, right? So are these the same? Yes. If I have a value and I'm adding something to it to get 180, if I take that same value, I have to add the same thing to it to get 180. So would the two angles be congruent?
Yeah.
Yes. So this is true. Okay, so those were kind of our math conjectures. Okay. All state names have at least 2 syllables. Do what?
False.
What's a state that doesn't have 2 syllables?
Maine.
Maine. False. Maine only has 1 syllable. Okay, last one. Squaring a number and adding 1 will always result in an even number. What's an example? 2 squared is what? 4 plus 1 is 5. 5 is not an even number, so this is false. 2 squared plus 1 is 5. What would be another counterexample? 4 squared plus 1 is 17. Okay? Good? Okay, now y'all get to have a little bit of your creativity. Okay? You are going to write your own 2 conjectures. They can be anything you want, any 2 statements. Okay? Like this one, all states have at least 2 syllables. Think of any statement you want to write. It can be math related, it can be not math related. Okay? These can't be opinion things though. They have to be something like, yes, that's true, or no, that's not true. Okay? So you're going to write whatever you want, 17 and 18. You get to write your own. Then you are going to switch it with partner, and then you are going to write true or false. Your partner is going to tell you, yes, that's true, no, it's false. And if it's false, then you write a counter example. Okay? So y'all are going to do this. This next part, mind your P's and Q's. This is just a graphic organizer for logic statements. We haven't really learned what these logic statements are yet. That's what we're doing the next 2 days. Okay? But we are just going to go over what the logic statement looks like and then write it in words. Okay? So a conjunction, use the statement below to write compound statements. P is vertical angles are congruent, and Q is 15 is a prime number. Okay, so our conjunction would be vertical angles are congruent. And it's like a couple back. And 15 is a prime number. Okay, that's how you write a conjunction. Okay, your conjunction, the shorthand, the symbols is P and Q. The first statement and the second statement. Okay, that little arrow up, that's an and symbol. Okay, P and Q. Okay, are vertical angles congruent? Yes, that's what we learned last unit. And is 15 a prime number? No, 15 is not prime. So is this true or false? This is false. So your truth value, we put an F for false. That is not true. Okay, now a disjunction is vertical angles are congruent or 15 is a prime number. So your conjunction is both have to be true. Your disjunction is one is true or the other is true. Could they both be true? Not in this example, but could they both be true? Could I make two statements that are both true? Yes. Okay. But a disjunction, one or the other has to be true. They both could be true, but one of them or the other has to be true. So vertical angles are congruent or 15 is a prime number. Is one of those true? Yes, vertical angles are congruent. So since it's an or statement, since it's a disjunction, only one has to be true. Since one is true, my truth value for this is true or false? True. The way we shorthand write that is P or Q. So this symbol means and, this symbol means or. Okay? Now we're going to look at our conditional statements. And again, we're going to go more in depth with each of these next class and then the class after that. Okay, use the statements below to write the conditional statements. Okay, conditional statements are if-then statements. Okay, so if it is St. Patrick's Day, then it is March. If-then statement. All of our conditional statements are if-then. Okay, so if it's St. Patrick's Day, then it is March. Does St. Patrick's Day always fall in March? Yes, so if I say it's St. Patrick's Day, do I know that it's March? Yes, so this is true. Okay, the way we write this is P implies Q. That's what that arrow means. This first statement implies this second statement. Okay? Now, an inverse. An inverse is if it is not St. Patrick's Day, then it is not March. Do we think this is true or false?
False.
False. Are there other days in March that aren't St. Patty's Day? Yes. So this is false. Not all days in March are St. Patrick's Day. Only one of them. So you can not be St. Patrick's Day, but still be in the month of March. Okay? So the way we write this, not P implies not P implies not Q. So your conditional is the first, implies the second. Your inverse is not the first, implies not the second. Okay? Now we're going to do the converse. The converse is the opposite of the conditional. So instead of P implies Q, it's going to be Q implies P. Okay? So if it is March, then it is St. Patrick's Day. If it is March, then it is St. Patrick's Day. Is that true or false?
False.
False, true. I heard both. That's false. Just because it's March does not necessarily mean it's St. Patrick's Day. It can be, but not all days in March are St. Patrick's Day. So this is false. Okay. So then the contrapositive is not Q implies not P. Then this one would say, if it is not March, then it is not St. Patrick's Day. Is that true or false? That's true. If it's not March, it cannot be St. Patrick's Day because St. Patrick's Day falls in March. So this is true. Okay, so then our biconditional is P. Then we have an arrow going both ways. What do you think this arrow going both ways means? P implies Q, but also Q has to imply P because it goes both ways. So that means P is Q if and only if Q is true. Okay, so the way we write this, if it is St. Patrick's Day, sorry, not if, it is St. Patrick's Day, if and only if it is March. So again, does this work both ways? If it's St. Patrick's Day, it's March. If it's March, it's St. Patrick's Day. Again, if it's St. Patrick's Day, it's March. Is that true? Yes. If it's March, is it St. Patrick's Day?
No.
Not necessarily. So is this a true or false statement? This is false. Okay. Okay, so let's write a little key down at the bottom. What's this symbol mean? And. What did this symbol mean? Wait till after I'm done. We're almost done. Wait till after I finish this. Okay? What's that symbol mean?
Right.
Implies. What's this symbol mean?
Both of them.
If and only if. And then, what's this mean? The squiggle. That's a not. Okay. Good? Okay.